Good morning, students. Your physics teacher Hassan Darwish with you. In this video, I'm going to talk about types of collision and do some application. Let's start. Okay, we said in the last video that during collision or explosion, the linear momentum of the system is conserved, right? Now we have two types of collision in reality, elastic collision and inelastic collision. Now, if the kinetic energy of the system is conserved, means remains constant during collision. I mean, kinetic energy before collision equal kinetic energy after collision. But this is for the system, not for one body. Be careful. The collision is elastic. Okay, means there is no loss of energy by the system during collision. As an example, collision between two marbles or billiard balls is almost completely elastic. Now, if the kinetic energy of the system is such that after collision is smaller than before collision, this means that the system loses energy during collision. Means when collision occurs, heat is liberated or sound is heard. Clear? It means, in summary, the system loses energy during collision. Then it is said to be inelastic. Okay? An important remark here. If the two bodies stick to each other after collision and move as one body, be careful here, move as one body, the collision is then said to be completely inelastic, okay? So let's take an application. The only required application from us is head-on elastic collision. What is a head-on elastic collision? In the head-on elastic collision, the velocities remain what? Collinear, say on x prime x, okay? Let's do an example in general. Two balls A and B of masses m1 and m2 move with velocities v1 and v2 respectively along x prime x, enter in a head-on perfectly elastic collision. Be careful. Elastic collision. Their velocities just after collision are v1 prime and v2 prime because they are changed. But be careful, the prime here doesn't mean derivative, means a new value, okay? Determine in terms of m1, m2, v1 and v2 the velocities v1 prime and v2 prime. Okay, students and boys, in reality, notice here, I deliberately didn't give you the direction of v1 and v2 before collision. You notice this? Why? Because I want to solve this exercise in general, and I am going to follow only one method, which you will follow always. Clear? You may learn it by heart. That's why I didn't pre-specify the direction of v1 and v2 along x prime x. So I want to solve it in general. Let's start with this. Okay. You know, during collision, what? The linear momentum of the system is conserved, right? So here, during collision, okay. It means linear momentum before collision, be careful. The system here is two balls, not only one ball. The linear momentum of one ball, A or B, is not conserved. Be careful about this. Both balls is conserved. So this is before collision. Linear momentum before collision. This is after collision. And notice here, the velocities are prime. Okay? So this is after. But you notice here, this equation is a vector equation. I cannot replace number. So what should I do? First of all, I have to get rid of vectors. But because the collision is head-on, means the velocities are collinear on x prime x. So I can eliminate the vectors. Clear? And here I have left, I eliminated the vector, means I dropped the vector, but keep the velocities in their what? Algebraic values. Why? Because I didn't indicate the direction of motion of each body on x prime x, right? So I can leave them in algebraic values. I mean, I eliminated the vectors here. This, you can do this only because the velocities are collinear, which is as I did in the previous example. Okay, as I did here in this example. Remember. Here, remember this example? I eliminated the unit vector, but keep v1, v2, v1 prime, and v2 prime in their algebraic values. I mean, the values could be positive number or negative number. Okay, remember? Good. But notice here, this equation contains two unknowns, v1 prime and v2 prime. You notice? Can you solve one equation with two unknowns? Surely not. So let's call this equation 1. We need another equation to solve for v1 prime and v2 prime. Okay, where do we get this equation from? Remember he said the collision is elastic, right? And what did we say here? In an elastic collision, the kinetic energy of the system is conserved, right? So let's apply this conservation rule. Good. Since the collision is perfectly elastic, the kinetic energy, as I said, is conserved. So means what? Kinetic energy half mv squared. This is for particle A and this is for particle B. And also be careful. Kinetic energy of the system is conserved, means for A and B. For one particle, the kinetic energy is never conserved. Be careful. So this is before collision, kinetic energy of the two bodies. And this is after collision. Okay? Be careful. Also, this is a second equation, which also contains the two unknown. But it's not easy to solve this mathematically. Why it's not easy? Because in this equation, it is linear equation, no squares. In the second equation, here, call it equation 2, it is quadratic, means they're square. So it's not easy to solve in general. This is tricky one. That's why I want you to follow this method, okay? Which we will always follow in all collision exercises, okay? Learn it by heart. Let's do the following simplification. I am going to write equation 1 in this form. Of course, you can cancel half here. You are allowed to cancel half, right? M1, this is equation 1. M1 into V1 minus V1 prime equals M2 into V2 minus V2 prime. Just I rearranged equation 1. Look here. I rearranged equation 1. Here, M1, take this 2 before equal. M2, V2, put it here. Okay? And take M1 common factor and take here on the right side M2 as common factor. Okay, any problem? So this is equation 1. Let's do the same for equation 2. M1 into V1 squared minus V1 prime squared equals M2 into V2 prime squared minus V2 squared, right? Be careful here, there is a mistake. Sorry for this mistake, excuse me. Prime is not for this, here is the prime, okay? You see? Here, M2 V2 prime minus M2 V2. This is equation 2, right? So how can I solve this system? Here is equation 2, just rearrangement. What do I do? If I want to simplify this system, in reality I want to cancel M1, M1, M2, M2. Notice here, V1 minus V1 squared is V1 minus V1 prime, V1 squared minus V1 prime squared. If also you want to cancel, try to factorize this and this. Notice, remember this equation, x squared minus y squared from mathematics is equal to, if you factorize, x minus y into x plus y, right? Remember this? So we'll do this for equation 2 and then divide 2 by 1. Okay. So here, the system, quickly, M1 into V1 minus V1 prime equal, be careful about the calculation, okay? M2, quickly, sorry. V2 minus V2 prime here minus V2. This is equation 1 and this is equation 2. M1 into, I'm going to factorize, as I said, x squared minus y squared. V1 minus V1 prime into V1 plus V1 prime, right? Similarly, for M2 into V2 prime minus V2 into V2 prime plus V2, okay? So this is plus here. Now this is equation 3. Here is equation 3. Now divide equation 3 by equation 1. Equation 3 over equation 1. Always follow this method. This is the only method, okay, to solve this exercise quickly. If you divide them, I can cancel, notes here, I can cancel this by that and this by that. So I get, not equation, sorry here, don't call this equation 3. So I can cancel this. So I'm left with V1 plus V1 prime is equal to V2 prime plus V2. Here is equation 3, right? This is equation 3. Now notice here, equation 3 and equation 1 are linear functions, so I can solve them. Now, replace, notice here, replace equation 3, I mean, sorry, V2 prime in, let me write it clearly here. V2 prime equal, here it is, V1 plus V1 prime minus V2, right? From equation 3. Replace it in equation 1, you get the answer. Okay? Any problem? Okay, I will leave the calculation for you. Take care. Bye-bye.